Hello and welcome back to the Azure DevOps course. In this lecture, we will explain how to auto-scale your Azure Pipelines agent inside Kubernetes cluster. So first, to have auto-scaling in Kubernetes, we need an autoscaler. Auto-scaling to external events is not built in Kubernetes cluster. So the autoscaler that we will use is KEDA. KEDA is an event-based autoscaler for workloads on Kubernetes. So it will autoscale our deployments, our jobs, when an external event happens. So it listens to an external event, and when that external event happens, it will autoscale. So our external event is the start of an job. When there is a job in the queue, the KEDA autoscaler works and autoscale our deployment. Then we have a new pipeline agent. So that is the autoscaling. So how we install this autoscaler inside Kubernetes? To install this KEDA autoscaler, we will use Helm, the package manager for Kubernetes. So I will click on install here. It gives me the Helm commands I will use to install the KEDA operator. Let's copy and I paste now. Now I'm adding the Helm repo, and that's the command Helm install will install KEDA autoscaler in my cluster. So now it is installed. The KEDA autoscaler is installed in our cluster. We can use it now. So to use the KEDA autoscaler to autoscale your Azure Pipelines agent, there is a blog from KEDA website it has made to explain how to do this, how to scale the Azure Pipelines agent using KEDA. So now there is two ways to scale your Azure Pipelines agent using KEDA. We can scale it as a job or scale it as a deployment. That is the tutorial above. But I will go with scaling as a job, because when you are running your agent as deployments, you have no control which pods get scaled when scaling down. The scaling down will be unstable and unpredicted. The time that the agent will scale down, it can scale down while there is a job running and using your agent. So when running your agent in a job, when the job is completed, the agent will be deleted. So if you run at a job, KEDA will start the Kubernetes job for each job in the agent pool queue, and the agent will accept one job when they are started and terminate afterwards. So our pipelines agent will terminate after the pipeline has finished. After the pipeline job has finished, our pipeline agent job will terminate and the pod will terminate. So that will be better, because when scaling up and down with deployments, you can go with unpredicted behavior when scaling down, because if it automatically scales down your deployments in a time where your agent is running now, it can lead to an unpredicted behavior. So it is better using job for each pipeline run. We will have an Kubernetes job that runs the pipelines agent for each pipeline job. So to do this, we have to define a scaled job resource in Kubernetes. This scaled job resource is a custom resource for the KEDA operator. So we can define this scaled job when we have installed the KEDA operator in our cluster. So that is a tutorial how to define a scaled job. We give it the deployment template, the container image, and the environment variables, and the privilege true. So I have created this scaled job YAML file. I will turn it back to Notepad++. I've created this scaled job YAML file. Here in the template, it's the same as a deployment. It contains the environment variables and our image, and also uses the secret token. And here I'm giving it args --1s. That args key means that we are giving the entry point of our Azure Pipelines image a parameter or a flag. This --1s flag, it is passed to the start.sh script. These flags makes the pipeline agent container exits and close after the build has finished. So if we used the pipeline agent in a build, in a pipeline, when the pipeline finishes, the Azure Pipelines agent will be deleted from the pool and the container will finish because of this flag. So the Kubernetes job will be completed and the agent will be deleted from the pool. So this flag is important. If you turn back also to the Azure documentation, here in the documentation, it says here, running it with a --1s flag at the end will shut down the agent after the build is executed. So the agent will shut down after the build, the pipeline build is executed. So that's why you are using the --1s flag. Okay, and here that is the max replica count. So that's the max scaling that we can do for the jobs. So we can't have an 11 job running simultaneously in our pipeline. The maximum is 10 for the scaling, so we can have only a 10 Azure Pipelines agent running in the same time. And that is important, the triggers. Here in the triggers, we specify that the trigger is based on Azure Pipelines. So that is will make your job, the scale job, listen to your Azure Pipelines server external event. Here we specify the trigger to be from the Azure Pipelines and give it the metadata for the pool name, and here the organization URL and the personal access token. It will take it from the environment variables here. So we don't need to specify it again. It will take it from the environment variables. That's the trigger will make this scaled job trigger when there is a new pipeline, when specifying it to be Azure Pipelines trigger. Okay, we can save now and try to apply this YAML file. I will apply now this YAML file, scaled job.yaml. Okay, and there is important thing I want to mention also. Here in the KEDA block, it says here, you can't queue an Azure Pipelines job on an empty agent pool. That means that you must have at least one agent in your pool so the pipeline can run and KEDA start listening to your external event. So if you try to run a pipeline when your pool doesn't have any agent, the pipeline will fail. You must at least have a one agent. Even if the agent is disabled, we can disable this agent or can be offline, but you must at least have only one agent in this pool. So KEDA can start listening to the external event and make the scaling. Otherwise, the pipeline will fail from the start and KEDA can't listen and make the scaling. So that is the placeholder agent. It is a dummy agent that is offline and disabled to have at least one agent so KEDA can start listening and pipeline doesn't fail from the start. Okay, so now we have applied the scaled job YAML file and have installed KEDA. So now we can start, try and run a pipeline that have multiple jobs and see how the scaling happens in action. So here I made a pipeline. This pipeline called the Kubernetes KEDA build agent. I will edit it. Here in this pipeline, it uses the Kubernetes pool and it consists of a matrix job. So this matrix job will loop and create 5 jobs for us. So we'll have 5 jobs running simultaneously. And in each job, it echo a different value for the variable test name. So in the first one, it will be job 1, second one, job 2. And it also print the agent name from the predefined variable and sleep 60 seconds. So you can see all the 5 jobs running at the same time. Okay. So now let's try to run the pipeline and see the Azure Pipelines scaling at the real time. So now I will run. And now there is 5 jobs. And now KEDA should scale the pipelines agent and create 5 pipelines agent. So it will take a time to install the 5 agents. But now there is 5 jobs in the queue. So the external event will trigger KEDA to scale 5 Kubernetes jobs that will install 5 pipelines agents. So here in the agent pools, now if we wait, we should see new 5 pipelines agents. So now they are installing. So now after waiting, there is new 5 pipelines agents installed in our agent pool. And if we return back, we should see now the 5 jobs running simultaneously with the new pipelines agents. And after each job finish, the pipelines agent should be removed and deleted from the agent pool. So I will wait now until all the jobs are finished. When they finish, the agent should be stopped and deleted from the pool. So now all the jobs are finished. If I return back to the agent pool, I should see all the pipelines agents are removed. If I return back and refresh, now all the pipelines agents are removed. So that's how great is the KEDA Autoscaling for the pipelines agent. It listens for your pipeline trigger, and after triggering, it starts creating your pipeline agent, and when the pipeline finishes, it deletes and removes your agent. So you have a new fresh agent for each pipeline job. So that's how great is the KEDA Autoscaling. So that was the end of our lecture. We have learned how to install the KEDA Autoscaler operator in the Kubernetes cluster and learned how to create a scale job that listens to the Azure Pipelines trigger and start creating a job for each pipeline job, and have run a demo pipeline to show the scaling in action. So I hope you like it and see you in the next lecture.